Today's day 7 of Unit 7. We started today with a homework quiz, so you'll need to make that up if you missed class. Then we did this warm-up, so take a moment, work on the warm-up. Pause the video and then play to check your answers. So number 1, we need to get the bases the same, so we're going to rewrite that with a base of 3. So 3 to the third is 27, and that's the x plus 2 power. And then 3 to the negative fourth is 1 over 81. So that's 3 to the 3x plus 6 and 3 to the negative 4. So now that the exponents are equal, we can set them equal. And 3x equals negative 10, which means x equals negative 10 thirds. Number 2, so get rid of the negative exponent first by the reciprocal of the base. So that's 125 over 1, which is just 125. So that's to the 2/3 power. So then get rid of the 2/3 by making it the cubed root of 125 and then squaring that. And the cubed root of 125 is 5, and 5 squared is 25. So that's my answer. Okay, so today we started our lesson with this problem. This is a review from Algebra 1, but it's been a while, so I wanted to refresh your memory. So this problem, the issue is that I have a square root in the denominator, and we know we need to simplify that. Well, I need to get rid of that square root, but there's an expression here with addition. It's not just the square root of 5. So we know if it was the square root of 5, we'd multiply by root 5 over root 5. Well, it's not just the square root of 5 though. So I need to multiply actually by 3 minus the square root of 5 over 3 minus the square root of 5. Very similar to how we simplified problems earlier in the year that involved an I. So if it said 3 plus I, we multiplied numerator and denominator by the complex conjugate. Same idea here. So that's how we're going to get rid of that rational number from the denominator. So distributing the 2 gives me 6 minus 2 root 5 in the numerator, and then I'm doing FOIL, first, outer, inner, last, or distributive property, but really all that matters are the firsts and the lasts, because the outer and the inner are going to cancel out. So I really just need to do 3 times 3, which is 9, and root 5 times root 5 is 5, but it's a minus. So that gives me 4 in the denominator and 6 minus 2 root 5 in the numerator. Now, the only thing I have to simplify there are 6, 4, and 2. I see that 2 goes into all of them, so divide each by 2 and get 3 minus root 5 all over 2. And that's my final answer. Okay, we also did a little bit of review today from Unit 5, solving problems involving square roots or just radicals in general. So we took a look at this one. So if you recall, the first thing we did when we solved these in Unit 5 was we're trying to get the x by itself. So I'm trying to undo a square root, and I undo a square root by squaring. So we're going to square both sides. So the squaring does the square root, and I have x plus 17. And when I square x minus 3 correctly, I get x squared minus 6x plus 9. So then I'm going to get everything together on one side so that the quadratic equation is set equal to 0. So I can solve. So subtract x and subtract 17 gives me x squared. Subtracting x from negative 6x is negative 7x. Subtracting 17 from 9 gives me minus 8. So I know at this point I can factor or use the quadratic formula or complete the square. Looks like this one factors pretty easily. So x minus 8 and plus 1. So then x is equal to 8 or negative 1. But remember, this problem involved a square root, an even root. So it's possible that there could be extraneous solutions. So I have to check both of these to make sure that they're correct. So the check means I substitute into the original equation one value at a time. So the square root of, we'll try 8 first. 8 plus 17, the square root of that should equal 8 minus 3. Well, 8 minus 3 is 5. 8 plus 17 is 25, and the square root of 25 is 5. So that works. Now I'm going to check the other solution. So square root of negative 1 plus 17 should equal negative 1 minus 3. So the square root of 16 should equal negative 4. Well, we're not solving an equation here. We're just answering what's the square root of 16. The square root of 16 is 4. That's not equal to negative 4. So that means x equals negative 1 is not a solution. It's an extraneous solution. And x equals 8 is the only answer. So we did a few more like that. So this one, same idea. I'm trying to solve for x. So I'm going to copy that in your notes. So if I'm trying to solve for x, I want to undo what's happening to x. But before I can even do that, I need to get this 2 on the other side so that I have just the fourth root by itself. So I have the fourth root by itself is equal to subtracted 2, so negative 2. Now that I have a fourth root, now I can undo that by taking everything or both sides to the fourth power. So the fourth power undoes the fourth root, which means 2x plus 3. And negative 2 to the fourth power is equal to positive 16. So subtracting 3 and dividing by 2 gives me that. But again, this problem involved an even root, therefore we must do a check. So the check, remember, goes in the original. So 2 times 13 halves plus 3, the fourth root of that, and then we're going to add 2 should equal 0. So we have the fourth root of 2 times 13 halves is just 13 plus 3. So the fourth root of 16 is 2, and 2 plus 2 is not equal to 0. So because I only had one answer and it ended up being extraneous, of course I'm going to cross it off, but then I'm going to write no solution because the one solution I thought I had is actually not a solution. All right, so another one, same idea here. This problem has a fractional exponent, so we know from our work earlier in this unit that a fractional exponent can be rewritten as a radical. So that's how I'm going to start this. I'm going to start it as the fourth root of x cubed plus 5 is equal to 32. So once again, to solve for x, I have to get that 5 out of there. So let me subtract 5 from each side. Now I have what I want by itself, so now I can undo what's being done in the reverse order. So if I knew x, I'd take the fourth root and then I'd cube, which means I have to undo cubing first, which means I'm going to take the cube root of each side first. Now that looks more crazy than it needs to. So cube root of 27 we know is 3. Remember, the cube and the cube root just undo one another, so kind of just cross both of them off. And when one undoes the other, I'm left with just the fourth root of x. So now I'm trying to solve for x, so I undo fourth root by taking to the fourth power. 3 to the fourth power is 81, and the fourth root of x to the fourth is just x. So I'm going to check that. So we're checking x equals 81. So we have 81 to the 3/4 plus 5 should equal 32. So the fourth root of 81 cubed plus 5 should equal 32. The fourth root of 81 is 3. 3 cubed is 27. 27 plus 5 is 32. 32. So it checks. Therefore, x equals 81 is a solution. Okay. So there's your problems you need to do for homework. And reminder, coming up on Thursday, you do have a quiz on everything we've covered so far in this unit. And also remember to keep practicing your exponents because we could have another timed exponent quiz any day now. So just keep practicing those. And there's an extra credit opportunity next week. Take a look at that and see if that's something you're interested in.